So here is the practice exam 2 for trigonometry in what is this, fall 2021. And let's just get started. So our first question down here, finding the exact values of A, B, C, and D so that the following graph fits the form f of x equals a cosine of bx minus c and then plus d. So we'll get to pick a little bit of everything. So let's start looking at stuff. First couple of things I'm going to want are my maximum and minimum y values. So I'm going to start off there, y max and y min. And the maximum looks like it'll be here at -1, while the minimum is down here at -5. So that'll let me put into the range -5 to -1. So that's what our range would be. Up next, suppose we could also calculate the period, which, since this is cosine, I should be able to look at the distance between two maximum values to get the period. And they hit nicely at some grid intersection points. So let's find out what that is. It'll be pi over 4 minus -5 pi over 2. Pi over 12, excuse me, -5 pi over 12. Simplifying that should get you to 2 pi over 3. Probably include some extra work somewhere here in a minute. And that's all of the information that we know for sure must be true. I also need to pick a phase shift somewhere. And we'd have a few options for that. Down here, I could choose a phase shift, or here I could choose a phase shift, or here I could choose a phase shift. So picking something that's either green or magenta can go in here for the phase shift. But let's go with pi over 4. I think that'll be the easiest one. But again, we get options on the phase shift. Could pick any one of those. But now we'll use all of that information to find the amplitude and the vertical shift, among other things. Starting with that amplitude, I'll have -1 minus -5. All over 2 compared to the vertical shift, which looks like I'm scooch down just slightly. The vertical shift is -1 plus -5. All over 2. Right, that being the difference between the two formulas for amplitude and vertical shift. So doing that math out, -1 plus 5 is 4 over 2 would be 2 for the amplitude. And -1 minus -5 is -6 over -2 is -3. Now that I know what my vertical shift is, I could draw that center line in just in case I needed it. It's at -3. Oh, that part is somewhat unnecessary since it's a cosine graph. If it were sine, it would probably be a bit more important. All right. So that means that once we know what the vertical shift is, we can also fill that in on our chart. -3 right here for the vertical shift. And we'll start applying that down here. So the vertical shift we already know is -3. A we know is going to be 2. Based on the choices I was picking for the phase shift, if I chose one of the green points, one of those 2 points highlighted in green, circled in green, A would be positive. And if I chose one of the phase shift circled in magenta, A would come out to be negative. So it will be either plus or -2. And if I continue with my phase shift choice of pi/4, it should be +2. But up next, we'll get B, which is 2 pi divided by the period, which in our case is 2 pi/3. So this thing should simplify to just 3. Up next, we'll want to get C. And C is always going to be B multiplied by the phase shift. So B multiplied by the phase shift. I will use green because I chose a positive phase shift. So this is going to be 3 times pi/4. So 3 pi/4. Slot 3 pi/4 into that box. So the final step is to write out an equation for f, which ours should come out to +2 cosine of 3x minus 3 pi/4 minus 3. And then as a bonus, just writing in an extra bit here, if we had chosen a negative phase shift value, so if we had started this thing at negative pi/12 instead of negative 3 pi/4, this thing could have been negative 2 cosine of 3x minus a negative pi/4 minus 3. So also a valid equation for this cosine graph. Since we could have come back up here, instead of choosing pi/4, say we'd instead decided to choose negative pi/12. I should scroll that up so we can still see the graph that we're looking at. So choosing to start down at a minimum, maybe we wanted to just choose the cosine value that was closest to the y-axis, meaning we would have started at negative pi/12, which would mean that C would come out to negative pi/4 after we did some math. And then the equation was down there at the bottom. So let's bring it up to the graph and just talk about a few things again. So recall that if I'm looking at a cosine graph, which we come back up to, I come back up to the statement of the problem. We were told this thing had to be a cosine graph. A cosine graph always starts at either the maximum or the minimum, which means we could start our graph at any maximum value or any minimum value. If we start at a maximum value, then we have a positive cosine graph. If we start at a minimum, we'll have a negative cosine graph. So pi/4 and negative pi/12 are just two of an infinite number of possibilities we could choose for the phase shift. Although in the part of the graph that's shown here, there are only 3 total phase shifts we could have chosen from. The third being negative 5 pi over 12. That's that one that's circled in green all the way to the left. Okay. But then let's move on to some new stuff. But real quick, answering a question that's in the chat right now. That is very nearly correct. Choosing the phase shift, the question is, the only thing that would change would be C if we change the phase shift. That is like 95% correct, because that's the only number that's going to change. But depending on our choice of the phase shift, the sign of A could also change. Right, so A we know is definitely going to be plus or minus 2. Right, the number on A is definitely 2, but depending on our phase shift choice, it could be either positive or negative. If I chose one of the green points, it would be positive, and if I chose the magenta point, it would be negative. All depends if we're starting at a maximum or a minimum. Right, up next, let's take a look at a multiple choice question. So which of the following is the best graph for 9 sine of pi over 2x minus 6? All right, so this thing doesn't have a phase shift, which means that we definitely want to start in the middle of our graph when we're at the y-axis. So judging by the graphs here, all of them look like they are sine, so that's good. So then let's see, what else do we have? We're shifting down 6 with an amplitude of 9. So if I were to look at maybe A, that one looks like it's probably a plus 6 rather than a minus 6. So A is not a very good choice. Looking at D, it's hard to tell exactly, but this thing has also been shifted up. So D is also not a great choice. Down here in C, even without looking too hard at it, that amplitude is not bigger than 6. Because just looking at the vertical shift in the amplitude, this thing should come back up above the x-axis. So for example, I should know that my range over here is negative 15 to 3. The way I'm getting that, I've got negative 6 plus 9 and negative 6 minus 9. Gets me to 3 and negative 15. So C is out because the range doesn't fit, which means B is the only good choice left. If I were trying to go with process of elimination there. But otherwise, looking at B, that thing has definitely been shifted down rather than up, and its amplitude is bigger than its vertical shift. So just pretty much by only looking at the range, I can say that option B is the only one that fits. Which is good because the graphs are kind of small, so that's the only real indicator that's the easiest indicator to look at anyway. I could really zoom in and figure out what the period is, but that's not necessary in the step. Just analyzing the range will be enough to get us that B is the correct answer. All right. Up next, which of the following is the best function for the graph shown? We have all sine graphs being our options. All of them have an amplitude of 2, which is good because this thing definitely has an amplitude of 2, but some of them are negative, some of them are positive. So if I look at my starting value, which is here and moving down, this thing must be a negative sine graph, right? Starting in the middle and moving down. So anything that's not negative sine, I can get rid of. So A, B, and E are all out. So I just have to decide if this thing is pi over 5x or 5 over 2x on the inside. So next up, I'll look at the period, which is 4 pi over 5. And then B, I know, is 2 pi divided by the period, which is 4 pi over 5. Simplifying this thing, 2 over 4 is going to be 1 over 2. The pi's cancel out. So this thing is 5 over 2. Meaning that option D is the only one left. Or, by actually looking at it, D is the one that actually fits the graph. Since B must be 5 over 2 and not pi over 5. All right, scrolling on. Oh, hey, we kind of had this question earlier. Listing all the phase shifts where the value of A is positive in the equation A cosine bx minus c plus d. So of the options listed, if A is positive, then my only options are negative 5 pi over 12 and pi over 4. For all the reasons that we talked about in problem 1, since it's the same graph from problem 1. If, for giggles, I decided that I wanted to look at this problem from another direction and instead wanted to find all of the phase shifts where A is negative instead of positive, then I'm only looking down here at this minimum value, which is negative pi over 12. So, and once again, we were looking at cosine, which means I want to look at maximums and minimums. All right, up next, number 6, listing all phase shifts, the value of A is negative in the equation f of x is a sine of some other stuff. So this time we're looking for sine. So that means I'm going to need to find my center line. So 5 and negative 7 are my range values. Darn, I couldn't quite tell if I managed to cover my sneeze there. Okay, so if my range is negative 7 to 5, that means that my vertical shift is going to be negative 1. So I'll help us out by drawing in that line. Looks like my ruler should be moved up just a little. Oh, hey, come on. Just a little. All right, and that'll let us pick out all of the phase shifts where A is going to come out negative. So there's one that's right here, and there's one that's right here. So those phase shifts are at negative pi and at positive pi over 2. This guy out here being at negative pi. Right, so I'm looking along the center line for where the graph moves down. And that should give me my phase shifts. This is for A being negative. If, turning the tables like we did on the previous one, if I looked at A being positive instead, then my only phase shift would be right here at -pi/4. At least of stuff that we can see listed on the graph. Since at -pi/4, we start in the middle, but then the graph moves up, making it positive sign. Right, next, we've got another sine function. This time we're going to go from the function to the graph. So finding the period, the amplitude, the phase shift, all that kind of fun stuff. So we might as well get the amplitude first, because that one's going to be pretty easy. I want the absolute value of 7, which is, just 7. Right, pulling that number from right here. So maybe just underline it so we can still see what we're working with. The period, might as well do that one next. I'm looking at 2pi/6. Since I want 2pi/b, that thing will simplify to pi/3. So pi/3 we'll put in for the period. For that phase shift, it's c/b. We're keeping in mind that C, I don't have space for this. C must be equal to -pi, since I've got 6x plus 6. So I've got -pi/6, which there's nothing really to simplify there. -pi/6 is our answer. Again, keeping in mind that C is negative, so we should have a negative phase shift. So this graph is being shifted to the left. Up next, we're looking for our y max and our y min. So we'll start with -3 on both of these guys. And in one case, I'll want to add 7. In the other case, I'll be subtracting 7. Which should get us 4 and -10. And then finally, when we're looking for the x scale over here, we want to take the period, which is pi/3, and divide that thing by 4 to get pi/12. So the x scale isn't as important in the current era of online exams, since you're just going to be looking to pick a graph from several multiple choice options. But in past times, or if we're taking an in-person exam, the x scale ends up being quite a bit more important, as we'll see here. I'm just going to sketch a graph out real quick. Bring up my ruler. I'm going to put the center line down so that this line is y equals -3. And then I'll need to get my range on here as well. Our maximum value was 4. Our minimum value -10. And then we need an x scale on here. So I can give myself a bit more space. Roughly that. And our x scale is pi over 12. So I just want to count out by pi over 12 in each direction. I can even go to 3 pi over 12 if I wanted, but I'm not going to end up needing that. But cool. Again, our x scale is pi over 12. So every tick mark, I want to count by pi over 12. Finally, one thing I'm using over here, negative pi over 6, which was our phase shift. That is equal to negative 2 pi over 12. So I want to start at the phase shift, which means starting at negative pi over 6, but I'm going to relabel it to be negative pi over 12. So then with the last bit, I just need to connect all of these dots, or plot this thing out and connect all the dots. We had a graph of positive sign, which means at the phase shift, I should start at the center line and then move up because it's positive. So one tick over, I should be at the maximum value. The next tick over, I'm in the center. One tick right, and I'm down to the minimum. Another tick, I'm at the center line again. And then if I did another tick after that, I'd come back up to the maximum. Then I'll connect these dots like so. Maybe move that one so it kind of lands on the graph that I drew. And cool, that's good enough for a sketch. If we come through and label all of these points, what we're looking at negative pi over 6, negative 3. We've got negative pi over 12, 4. We've got the point here at 0, negative 3. Pi over 12, negative 10. And pi over 6, negative 3. So if I were to label, a few key points on here, these are the ones I would label probably. Let's move that over there so it's a little bit easier to read. Maybe move this one a little over to the left so it's not in the way. And then we could also see that this graph could continue going in both the left and the right directions. Oh, that part's not totally necessary. Try that one more time now that my mic is on. Cool. Moving on to the next problem, we have trig identities, which I'm sure are everyone's favorite. And yeah, let's just work through this one. Starting with part 1, I want to change anything that's a negative theta or a pi over 2 minus theta into its counterpart example. So scanning through this first one, cosecant of pi over 2 minus theta, that's a cofunction identity. Cofunction of cosecant is just secant. So secant theta times cosine of negative theta is just going to be cosine theta plus tangent of negative theta. I can pull that negative out because tangent is odd. So minus tangent of positive theta. Theta. And then another cofunction identity on tangent this time. That'll be cotangent theta. All right, so cosine is even, which means that the negative that's on the inside doesn't impact the function at all. Tangent is odd, so that negative needs to get factored out. So then I have secant theta times cosine theta minus tangent theta times cotangent theta, which if we wanted to do one more step here, secant theta is 1 over cosine theta times cosine theta minus tangent theta times cotangent, which is 1 over tangent theta. 1 minus 1, that's equal to 0. Yeah, maybe we'll just call this 1 minus 1 equals 0 if I show a few extra steps. So 0 is going to be our answer. And we should hopefully scroll down to the answer box and see over here. Cool. We have an answer. If I'm having some sort of multiple choice bank that goes out this far, I usually like making 0 and O be the same letter, just because I think it cuts down on some confusion. But anyway, option O. Option O, option 0. No, O is the wider one. Since O and 0 tend to look a lot alike. All right, up next. Looks like we've got a few Pythagorean identities going on. So if I look at that thing, 1 or secant squared minus tangent squared, that's a Pythagorean identity. It's equal to 1 over 1 plus cotangent squared is cosecant squared. So that one versus that one. Secant squared minus tangent squared is 1. 1 plus cotangent squared is cosecant squared. If we simplify that, 1 over cosecant is sine. So this thing must be sine squared theta. So hopefully sine squared of theta is an option. It is. H. All right, and up last, secant of negative theta times tangent of pi over 2 minus theta. Secant, again, just like cosine, is an even function. So secant of negative theta is just secant of theta times tangent of pi over 2 minus theta. I'll need a cofunction identity, so that thing is cotangent theta. If we then rewrite some of this stuff, secant is 1 over cosine. Cotangent is cosine over sine. Keep our colors going. Cosine over sine is cotangent. So those cosines should reduce with one another. Meaning we're just left with 1 over sine theta or cosecant theta. Hopefully that's also an option in here somewhere. It is option E. And if we move this thing on to one last trig identity problem, this one's a bit longer and a bit more complicated. But that ought to be okay. So let's see how much of this we can get through. So if I just take a quick look at the problem that's above. The only thing I'm going to leave alone in the first step is going to be that tangent x. Everything else is going to have something happen to it. So let's talk about what all that stuff's going to be. I guess we'll start in the denominator, that cosecant of pi over 2 minus theta. I'll need a cofunction identity there since I have pi over 2 minus theta. And that thing is secant of theta, or I guess secant of x, because x is our angle this time. Cool, so our denominator should change from cosecant, pi over 2 minus x, to just secant x. Cosine of negative x. Once again, cosine is an even function. So it's just cosine of positive x, positive cosine of positive x. Cotangent, however, is odd, so that negative should come out. Negative cotangent of x. And then lastly, we took care of all of our cofunction identities and all of our even and odd identities. I also have a Pythagorean identity right here. Secant squared minus tangent squared, that's just equal to 1. So up next, I'm going to get some things out of the denominators. I have a secant in the denominator right now, but I could bring that up to the numerator as cosine, since 1 over cosine is equal to secant, or 1 over secant is equal to cosine, sort of either way, times this will be 1 plus tangent x. Over here, I'll have minus cosine x times tangent x. I'll use that red x to track where that cotangent went. Right, so that cotangent in the denominator would be the same as bringing a tangent up to the numerator. Since tangent and cotangent are reciprocals of one another, then in this step, I should be able to multiply that cosine all the way through. So I'll have cosine x times 1, which is just cosine x, plus cosine x times tangent x. Slide that left just a little bit. Minus, this is cosine x, tangent x. At this point, I have a cosine times tangent minus cosine times tangent, meaning that only cosine of x remains. At which point, since we're trying to say that this thing was equal to cosine of x, we have proved our identity.